All right, ladies and gentlemen, good morning to you. Sorry for the late start. I was in a meeting here, and Alfred, Panawat, Hector, good morning to you. Okay, so good morning to all of you guys here. I hope you guys have worked very hard this weekend on law of what? Sines. We now have law of cosines. Okay, so let's do this law of cosines. Now, you might say, what in the world is law of cosines? A, what's this? B, and C. Okay, well, you're going to use laws of cosines in this situation, okay? There's two situations when you have the following. Side, angle, side, and what's the other one? Side, side, side. Okay, and so we got this portion here called little c, little a, little b. So I'm going to give you law of cosines this morning. I'm not going to prove all these cases there. You can watch your book. It's pretty interesting. But here you go. There's actually three versions, and they're all equivalent. Here's the deal. You have what? A squared is what? B squared plus C squared minus 2BC cosine C. B squared is what? A squared plus C squared minus 2AC cosine of B. And I apologize, that's cosine of A. Okay, and now you have C squared will be A squared plus B squared minus 2AB cosine C. So it's kind of like the Pythagorean theorem. You see this here. You got these three sides. You got cosine A, cosine B, and cosine C. These big angles here. So you got little a, big A. Little b, big B. Little c, big C. Okay, so if you are trying to find that A value, okay, hopefully you have this angle here, as you guys can see. Maybe we should change those colors. B, B. What else here? C, C. There you go. Okay, so I'm going to give you these other colors here. Maybe that helps you see. All right, you guys okay with that one? Now, probably, like I say, a good example to see in my mind, and I have to make sure I get some here. Let's see how to use this. Here's how we use it. Okay. All right. How about something like this? $42.3 degrees, 10.8, maybe 16.5. Okay. And I'm going to tell you what kind of situation is this here? Side what? Angle side. So you see here, you say, what does this mean? There's a what? Angle between what? Two sides. So here's the deal. Side, angle, side. Okay, you guys okay with this? So you might say, how in the world do I handle this? You know what I say you should do? Take a look at this here. You're going to call this little a, right? So notice again, you have this situation where you have a side and you have an angle opposite that, and then you have these two sides. So here's what you have here. You have what? A squared is what? B squared plus C squared minus 2BC cosine A. Let's get this out of here. So here's what we're going to write down, right? You have what? A squared going to be, now in my mind, ladies and gentlemen, this situation, it doesn't really matter what you call A or what you call B and C. Okay? It doesn't really matter. So you say, why not? Because, I mean, you can call this little b, you can call this little c. This is going to be what? 10.8 squared plus 16.5 squared minus 2 times 10.8 times 16.5 cosine 42.3. And so you got here, A is going to be the square root of what? 10.8 squared plus 60.5 squared minus 2 times 10.8 times 16.5 cosine 42.3 degrees. There you go. So I want to point out, if we say, well, let's do this by colors, right? If B is orange, so you guys can see that, and it's not that big a deal. B is orange. Then you have green. So we have this orange and green, orange, green, orange, green, and then you say, well, what is this angle A? That's the blue angle. And there it is. So we're going to get out the calculator. Here we go. Okay, so let's go to the TI here. And you say, well, what do we do? Well, let's kind of back out there. Second square root, what do you have here? 10.8 what? Squared plus 16.5 what? Squared minus 2 times 10.8 times what? 16.5, is that right? You notice that? Then it's going to be times what? Cosine of 42.3. What's this going to be? 11 point what? 2. Okay, so this is going to be 11 point what? 2, ladies and gentlemen. Okay, so if this is 11.2 now, little a, here we go. Okay, so far so good. All right, now notice what we need here. Let me go back over here. Notice what we need. What do we need? What's missing here? We have 2 what? Angles are missing. Is that right? So what do you have here? How do we get angle C? How do we get angle B? Because there's 2 missing. Notice once we get one, we could get the other. Is that right? Okay, I want you guys to know, pick an angle. Which angle do you like? Just any angle. B or C? Is that B? B or C? So you're going to use a little bit of algebra. Remember, what is this called? Law of cosines. So using some algebra here, we get cosine of what? B. Is that right? So here we go. 2, and you guys know about translation with algebra? Do you guys know what I'm talking about when I say translation? Do you guys know what that means, to translate? To translate means to move. So I could move terms across my equality sign, okay? You guys okay with that? and I'm really not moving them. It looks like we're moving them, so we're going to move them across this way here. Okay? We're going to move this across this way. So you have 2ac cosine b becomes a squared plus c squared minus b squared. Okay, you guys okay with that? Notice, what did I do? You see the sign over here, how it's negative? What is it on the other side? Positive. You see the sign over here for b squared? It's positive. What is it over here? That's my point. Okay, so we can do this. It's called translating. It's not really translating. It's not moving anything at all. You say, what are you really doing? You say plus what? Plus 2ac cosine b. 2ac cosine b. And then subtract the b squared. So here you go. This now means I can divide both sides by 2ac. 2ac, and what do you get? A squared plus c squared minus b squared over 2ac. You okay with that? Okay, so this is cosine B now. We're going to find that angle B. So all you got to do is plug in the values. You say, what are the values? Well, we know A is 11.2. So this would go up here. Okay, let's put that over here. A is 11.2. What's C going to be? 16.5. And then what's B going to be? B is going to be what? 10.8. We have that over here. Okay, you guys see that there? So we're going to use that 10.8 here. So here's what we're going to say. Here's your process. You guys want to follow this process. You get to use that in your calculator. Okay, now what you're going to get over here, so you guys know, is you're going to get a number like you guys did before. Isn't that a number? You're going to get this number here. And you're trying to find what? Angle B. How do you get that angle? B will be inverse cosine of what? 11.2 squared plus 16.5 squared minus 10.8 squared over 2 times 11.2 times 16.5. Okay, we're going to use that inverse, again, cosine function key. We'll learn more about that, but I want you guys to know, I'll put this here. This is called inverse cosine. We can do this to get angle B. I know that, they talk about inverse functions in 125 and these other classes. So let's see what we get now. Okay, you guys ready for that? There we go. Inverse cosine. Put an extra parentheses. Okay, so let's look at the details here. You say the first parentheses, I have to do what? If I go back here, notice this. This over what? This. And I should probably change my colors here. Orange over green. And here's the deal. you're going to have what? 11.2 squared plus 16.5 squared minus 10.8 what? Squared. Close that parentheses. And I apologize because you haven't seen that here, right? So let me get a little bit bigger. I hope you guys can see that. I'm gonna do this here. I'm putting a set of parentheses within another set of parentheses. Now we're going to divide here. And you're going to divide by what? What are you going to divide by? You're going to have 2 times 11.2 times 16.5. Close this here. Okay? And then you're going to hit what? Enter. So if this is in degree mode, and it is, what do you think that represents, ladies and gentlemen? Anybody know what that is? That's the angle B. And we're going to say, let's go out to the whole angle. I mean, we can go out to the decimal and say it's 0.5 to just be a little bit more accurate. So let's not do that. Let's go out to the tenths. And this is your angle B now. All right? You guys okay with that? You got angle B. 40 point what? 5%. So here's what you get. Not percent, sorry. Degrees. So now you got B. Guess what? Once you get B, can you get C? You guys see what I'm saying? Once you get B, we get C. How do you guys get C now? Good. 180 degrees minus what? 42.3 degrees minus what? 40.5 degrees. And what do you have here? All right, what do you get now? $180 minus 42.3 minus 40.5. And what do you end up with here? 97 point what? 2 degrees. There it is. So this is how you solve a what? This is how you solve, what do you solve? A triangle. Okay, you're going to use law of what? Cosines. And like I said, I think in some ways, even though they give you, I know when you first see this, they give you like 3 formulas. In my mind, I only know one formula. And I can share with you that one formula. Okay? It's kind of easy in a way. All right? So here's your sine angle side. Now, you say, what about the other situation? What if they give you now, for example, a what? A side situation. Okay? A, what? B, what else? C. Okay, and you get what? 15, 9, and 6. So notice what they gave you. They gave you what? Side, what? Side. So how would you guys go about finding all the angles? Yeah, pick an angle. What angle do you guys want to pick? A? Okay. So maybe I should share with you guys how I see this here, okay? So if that's A, this is little a, is that right? So what I see personally, here's what I start with. I know then, notice this, these are opposite sides. Is that true? These are all what? Opposite what? So here's the deal. What do we have here? A squared equals, you see this, always start with that side, A squared. Now, what are the other letters? If A is on that side, what are the other letters? So I say B squared plus C squared. You guys see how that looks like Pythagorean theorem? Right? You guys okay? This is like a memorization device. So it's minus 2 BC cosine of what? A. All right, you guys okay with that? Okay, so what do you guys think you should do with this? You could do a couple of things here, right? Maybe you want to say it this way. Maybe if you said, Mr. Judge, I know I'm going to have to solve for what? A, right? I'm trying to find this angle. Maybe I want to solve for cosine, right? This is what I mean. Move it to the other side. If you move it to the other side, what do you get? 2bc cosine A is B squared plus C squared minus what? A squared. Divide both sides by 2bc, what do you get? Cosine A becomes what? B squared plus C squared minus A squared, everything over 2bc. Okay, so then what should we do here? Do you guys know? What's little a? Isn't it 6? So this goes over here. This is 6. This is a little a. Remember I said to you, it really doesn't matter what the other, what you call B and C for the other sides. You know, it's not going to matter. You say, why not? Because if I put here, see this B squared and C squared, right? Right in here. It won't matter what you call them because you're adding them and squaring them anyway. What about down here? Does it matter? The order in which you multiply doesn't matter. So just kind of as a memorization device, here's what I have. Now, B and C got 9 and 15. Like I said, I'm not even going to look at them. This could be 9. This could be 15. This is 9 and 15. So what you have here is this. Cosine A becomes what? 9 squared plus what? 15 squared minus 6 squared, everything over 2 times 9 times 15. Now, what does that mean for you? It means A is inverse cosine of what? 9 squared plus 15 squared minus 6 squared. 2 times 9 times 15. Okay, you guys okay with that? So notice this. This is going to give me A. So I just know opposite sides. All right, you guys okay with that? That's going to give me A. Now, here's the deal. You say, what's the next part? The next part is just to use your calculator. So it's in the calculator. Okay, let's go to the TI. Remember, this is going to be in my numerator, and then this is going to be in my what? Denominator, okay? So let's try that out. So remember, hit inverse cosine, because this is an inverse cosine. There's the inverse cosine key. You might not have seen that. I'm going to do it again. I'm going to clear it out so you guys can see here. Right? There it is. Clear this out. Remember, it's in blue. So hit second. That's your inverse cosine. So go back here, and this is what I'm saying to you. You're using the inverse cosine key because you have cosine of A. This is what's going to allow you to get angle A in the calculator. So here you go. We're going to have what? 9 squared plus what? 15 squared minus what? 6 squared. We're going to close that, divide that, and what do you end up with? Now the denominator. You say 2 times what? 9 times what? 15. And do a double parentheses, right? So what do you have here when you end up with that? Uh-oh. That's really odd. Did I do dimensions for a right triangle? What did I do? Oh, well, it should work out. Let me try it again. Let's try it again. Second inverse cosine. Okay, now put in parentheses. 9 squared plus 15 squared minus what? 6 squared. Close that, divided by 2 times 9 times 15. Close that again. Yeah, I must have put a right triangle because cosine 90 is 1. So, I got to change the dimensions. I got to change the dimensions. Change the dimension. Let me double check. Let me do this here. I'm going to check 15 squared. Okay. 9 squared plus 6. Where's the square? Oh, something's wrong here. All right, let's double check here, okay? Uh, 2 times 9 times 15 down here. All right, let me double check here. Apologize. Let's go back to the TI here, okay? So let's get this in the TI. Now, inverse, let's find what this number is here. Just, we could do it this way. We'll try 9 squared. Let's go back, parentheses, right? Close that, divided by, parentheses here. 2 times 9 times 15. Yeah, so cosine is going to be 1. Okay, so that's kind of a weird thing here. Do we do that? Right triangle? So cosine of 90 degrees. No. Cosine of what? Okay. So the problem is when you make it up, you don't always get what? That angle. Okay, I'm just going to do something here. Oops, wrong computer. Where is the keyboard on this? Oh, it's over here. Okay, let's change some of the numbers here. Sorry about that. Let me go back and get this here. 1285, I guess. Okay. Let's change this on you guys, okay? Let's try that one again. 12, 8, 5. Sorry, I'm going to get some water here. Mm-hmm. Okay. So let's try that one again, okay? You guys remember this. You say pick an angle. And this time again, we're going to say A. So this is the little a. So pick the A version, and you now have this equation to solve, and now we can plug it in. What's little a again? It's 5, right? So remember now, I'm going to say this is 5 for little a. And then that means B and C, these others, it really doesn't matter. 8 and what? 12. So we're going to do 8 and 12. 8, 12. 8 and 12. Cosine A becomes the following. 8 squared plus 12 squared minus 5 squared over 2 times 8 times 12. So what does that mean about cosine then? A is going to be what? Inverse cosine. And you have what? 8 squared plus 12 squared minus 5 squared. 2 times 8 times 12. Okay, and what is A going to be? Let's try it out again. Here we go, okay? So enter, again, second inverse cosine. You now have that numerator to do. You say, what's the numerator? It's all of this. And then this is going to be your denominator, okay? So, okay, let's try that one out. So, we have 8 what? 8 squared plus 12 squared minus what? 5 squared. Close that, divided by 2 times what? 8 times 12. Close that again. Okay, now, we did inverse cosine. Is that right? So what do you think if we did inverse cosine, what do you think this angle represents, right? It's going to be, and it's in degree mode, right? So let's go out to the tenths again. So what I'm saying is that we found angle A, it's 17.6 degrees. Okay, you guys okay with that? So I just really highly recommend just knowing in some ways one formula. And the others will follow. And you say, what do you mean about B? If you wanted angle B now, what would you do again? Use law of what? Cosine. So for B, you say, how do you do B? It's really simple. B squared. Put little b. Now, what are the other letters? Say a squared plus c squared. Now, use those same letters. It's minus 2ac. So I want you guys to notice this. It's the same letters here. This letter and that letter, they're over here. But then you're going to say cosine of what? Big B. Cosine big B. Okay, you guys ready for that one? Okay, now you say little b. I'm trying to find cosine b. I'm really trying to find b. So what's opposite of this angle b, right? What's opposite here is what? Is 8. So I'm looking at the b and the 8. So, okay, you have what here? Right? Well, we're going to have to solve, right? So do the translation here, right? Move this over here and move this over here. What do you get? You get what? 2ac cosine b, which is a squared plus c squared minus b squared divided by 2ac. This is angle what? Angle B. You guys okay with that? So what was little b again? Right? Little b was 8. So you say, where does that go? That goes over here. So I always start with that. And then you have A and C. So what's A and C? Right? 5 and the what? 12. So it doesn't matter which one you call A. It doesn't matter which one you call what? C. It doesn't matter because the order in which you add doesn't matter. And the order in which you multiply doesn't matter. So you could just say this is cosine of B now, and it's 5 squared plus what? 12 squared minus 8 squared, everything over 2 times 5 times 12 here. Okay? So remember, it doesn't matter which one's B and C, really. And then you're going to use inverse what? Cosine. Good. And what do you get? 5 squared plus 12 squared minus 8 squared over 2 times 5 times 12. So let's go to the TI. Remember, this is going to be our what? Numerator, and then this is our what? Denominator, okay? Top and bottom. And this is really now, you have to really get good with that, right? You're going to say second cosine, parentheses, what's the deal? 5 squared plus what? 12 squared minus what? 8 squared. Divided by, what's this? 2 times 5 times what? 12. Close that twice. What angle is this? Well, if you go to the nearest tenths, you look at the digit to the right of the 9, it's a 5. That means add 1 to 9, and what do you get? 10. So even if you went to the tenths, this is approximately 29 what? 29 degrees. All right, now here's the deal. 180 minus 17.6 minus 29 degrees. $180 minus 17.6 minus 29 degrees, ladies and gentlemen. And your answer is going to be, what's the answer? 133 point what? 4 degrees. There it is. All right. So really, there's only 2 cases here, ladies and gentlemen. What are the 2 cases? Side, angle, side, or side, side, side. And there's a lot of examples where you use side, angle, side. A lot of examples, like, you know, so what I'll do here for this, I'm going to have you guys try a few here, okay? I want you guys to solve the triangle. Because there's a lot of examples, there's a lot of applications that we want to look at that do just that. Okay? Solve this triangle. So if I said this is going to be 62 degrees, 12, and 20. Now, I do have to be careful with some of these when you make up examples because, like I said, you know, these triangles are actually unique in that sense. So you got side, angle, side. Okay? Side, angle, side. So if you like, you could still do what? Use the A, use the B, use the C. And then for the second triangle, you're going to do the same. A, B, C. I have to find those. Oh, here we go. We do 10, 11, and 4. Okay, so you have the side, side, side situation. Okay, we're going to give you guys some time to do this. Not too bad, ladies and gentlemen. Good stuff. You got to use your calculator. If I can find I can never find it. Oh, there it is. It's on the corner. Okay. Give you guys some time. All right. You guys at home, you probably couldn't hear me. Hello? They didn't hear what I said. Hello, anybody there at home? All right, what do we have here? D equals the square root of 12 squared plus 20 squared minus 2 times 12 times 20 times cosine of 62 degrees. So you're going to say square root. So you say second. There we go, square root. Okay. Now you get to put what? 12 squared plus 20 squared, right? Minus 2 times what? 12 times 20. Cosine of what angle? 62. Is that right? 62 or 63? Okay. And you got to make sure you're in degree mode, 17 point what? 9. Okay. So you must make sure you're in degree mode too. So this is going to be a 17.9, ladies and gentlemen. So that goes way up here. Okay. You go, oh, is that 17.9? It sure is. Okay, and now you say, but Mr. Judge, how do I get an angle? Right? You say, that's fine. How do I get an angle? Okay. Change this one over here to theta. So far, so good? So where do I start, really? If that's theta, isn't this the opposite side? Okay, you guys okay with that? So what does law of cosines say? This is law of cosines again. 12 squared equals, isn't that opposite? What are the legs? 20 and 17.9, is that right? So what does that equal? 20 squared plus 17.9 squared minus 2 times 20 times 17.9 times the cosine of what angle? Theta. We don't know what that is. We're going to try to find that angle. So I don't have to even use vertices like A, B, and C. I just know angle that's opposite a what? That's the opposite side and the angle. Theta and 12. Okay, so what do you guys want to do now? Translate, right? So you say, what are you doing with this translating? Moving on the opposite side. So that means 2 times 20 times 17.9 cosine of the angle I'm finding is going to be, if I move it on the other side, I have the 20 squared plus 17.9 squared. I'm moving that 12 squared to the other side on the left. It's now negative. You guys see what I'm saying? So you get to move from the algebra. You're almost there. Now divide both sides by what? 2 times 20 times 17.9. 2 times 20 times 17.9. And you now have what? Cosine theta is 20 squared plus 17.9 squared minus 12 squared over 2 times 20 times 17.9. So what does that mean about theta then? Inverse cosine of what? 20 squared plus what? 17.9 squared minus 12 squared. Everything over 2 times 20 times what? 17.9. All right, you guys okay with that one? So what's our angle theta going to be? It's inverse cosine. So here you go. Second, inverse cosine, parentheses, we have what? Well, remember, go back to what we have here, right? Numerator, denominator. Okay, so 20 squared plus 17.9 squared, right? Minus 12 squared. 20 squared. Oh, go back. Here's a square key. Oh. I'm going to clear it out. Squared. What angle is this? 36 point what? 4 degrees. So, ladies and gentlemen, sure enough, I can get what? That 36.4 degree angle here. And does that free me with getting the other? (180 degrees minus 62 degrees minus 36.4 degrees. (180 minus 62 minus 36.4, and what do you get? 81 point what? 6 degrees. And there it is. You guys solved a what? Triangle. Okay? Now, we'll finish the next one tomorrow. I'll put some homework in, our section, but we'll do some more tomorrow. But ladies and gentlemen, you'll see when I say to you, we'll start working at some applications as well, that you kind of only need to know one formula. In all honesty, I look at it as really only one formula. I could deduce the rest because I memorized them kind of, right? But a good way to memorize a formula is every time you use it, you write it down. That's the thing. So, okay, you guys, we'll see you guys later. Okay, good morning, everybody. Good morning to you guys. Let's see here who's out there. Good morning to, who do we have? Alfred, good morning. Caesar, good morning. Good morning to all of you guys here. This nice, cool morning. Anyway, this was a law of cosines question, right, that we looked at yesterday. Is that true? All right, you guys okay with that? You guys know what I'm talking about? Okay. All right. So I think I gave you guys this one. So what I'm going to try to do again, I'm going to give you guys a way that I look at this. I'm going to take away the vertices. I think this is the most personally effective and efficient way. Because whenever I see these now, I know maybe you say, no, I'm not ready for that. I want to use the A, B, and C. Okay, you can do that. That's not a problem. But what I want to share with you guys is something kind of fundamental. Okay? Maybe I'll call that one A. I don't even call it an A. But law of cosines, if you just memorize one of them, that's a pretty good thing to do. Okay? Because what I can say is this. Remember this idea of being opposites, right? You want to get this angle? That's opposite the angle. So that, whatever letter you call it, is opposite. Law of cosines always says that number squared will be, okay, going to erase that. That number squared will be, now you look at these other sides, and it doesn't matter what you call them, 10 squared plus 11 squared. It looks like Pythagorean theorem, right? So then now you say, well, what's the rest of this? Well, that's 2 times 10 times 11. Cosine of that angle we call theta. So what I want to remind people of is, you have these, sides, and then we could get really that angle theta, because we're going to have to find cosine theta now. Okay, so in my mind, I don't look at A, B, C and try to coordinate it that way at all. I think this is just a little bit more efficient in some ways. And then I'll say to you, well, what do you guys do now? Remember this thing we called translation, right? I said you can translate. Translate in this case means to move a term. And it's to move a term to the other side of an equation. So move a term to the opposite side, left, right, of an equal sign. Okay, now you say, what does that mean? I'm going to move this to the other side. So what you now see here is a what? 2 times 10 times 11 cosine of theta. And then move what? This to the other side. And what do you see? You see a what? 10 squared plus 11 squared minus 4 squared. Two times 10 times 11. There you go. Okay, you guys okay with that? So this is kind of just solving some equations here. Now, what do you guys want to use here to get to theta? Do you guys remember yesterday? What do you guys use to get to theta? Right? We need theta, don't we? So what do we use? Use what's called the inverse cosine. Okay? So in this case now, we have what? theta equal to inverse cosine 10 squared minus 11 squared over 4 squared, 2 times 10 times 11. This is going to be what again? Inverse cosine. So, okay, let's get out the calculator. I got to wake up my TI. Okay, we're going to wake up that TI. What did you guys get, by the way, when you did this? Anybody get an answer? You can verify it. You know. Okay, so let's get to that calculator here. We're going to clear this out. You want this to be set to what? Degrees, right? So how do you check that? You go to mode, and then hopefully it's on degrees. And I know it is. There it is. It's on degree. Okay. So, okay. So we're going to go here. Inverse cosine. Remember, we need a numerator again. Right? And I put a parentheses there because what's going to be in that first set of parentheses is my numerator. Then I'm going to divide by my what? Denominator. Ten what? Squared plus 11 squared minus 4 what? Squared. Close that, divided by 2 times 10 times 11. Close this also. Okay? So what you're seeing here is the orange divided by the what? Green. Let's make sure our computer is plugged in. It is. We don't want to do that, have that experience. What did you guys get here? What's that angle? 21 point what? 21.3 degrees. And there you go. Okay, you guys okay with that? All right. There you go. All right. So I know this is going to be now 21 point what? 3 degrees. Did you guys get that one? Good job. Okay. So if you didn't, you guys want to copy this stuff. It's doable. Okay, now erase that here. Now, you say, okay, Mr. Judge, how do I get the other angle? Do the same thing. You might say, what's the same thing? Which one, maybe we call this theta, okay? Now you say, well, what is the same thing? Well, I need the opposite what? Side. Always remember the opposite side. So by law of cosines here we go. Here's what you got. 10 squared equals, remember how we do this? These are the other legs. Think of it like Pythagorean theorem, although it's not Pythagorean theorem. Now you do 2 times 11 times 4 times cosine of that angle theta. So this is what I do personally when I think of law of what? Cosines. But I got to show you the book, and the book is good too. It's just a matter of which approach you like. It's the same thing. Okay, so don't look at that and go, oh, I'm being taught something different. So here you go. 11, 4, 11, 4, and what's this? 10. And we're going to find this angle theta. Now, remember, the whole idea now is going to be what? Solve for cosine theta. Okay, and again, the algebra, you do the same kind of thing. Right? We're going to translate. Okay, so what does translate mean? Move this term to the what? Opposite side. Move that term to the opposite side. So you now get 2 times 11 times 4 cosine theta is 11 squared plus 4 squared minus what? 10 squared. Divide now by what? Whatever is multiplied to cosine theta. What's cosine theta? 11 squared plus 4 squared minus 10 squared. Everything over 2 times 11 times 4. Okay, you're going to find theta. You say, what is theta? Okay. All right, so now remember, we're going to do what here? You're going to do these kind of things. Okay. We're going to enter that in our calculator. So let's see what happens when we do. Okay, second inverse cosine 11 squared plus 4 squared minus 10 squared. Close that, divided by 2 times 11 times 4. And what do you guys get here? What's theta now? 65.1 degrees. So you guys can do this, ladies and gentlemen. This is now 65.1 degrees here, right? So once you get this angle, you got 2 angles now, right? So you say, oh, this is the angle I got, 65.1 degrees. What do you think you guys do now with this? How do I get the third angle? Do your sum of what? The interior angles of any triangle is 180. So that'll be 180 minus 21.3 minus 65.1. What? 6. And there you go. And there it is. And that's the process. What do you guys think? You get to use your calculator. You know, and so what I want to talk about today here, this is the law of cosines, and you get to do some more. We can do some more. You can see what we're doing here with this. You know, but at times we have to deal with these applications, right? So what I'm going to do now here is I'm going to draw some pictures here. And I'm going to put over here, this is an object here. It doesn't matter what that object is. And we're going to try to actually think about how we can answer these questions, okay? Now, I'm not going to put any words here. I'm just going to put some symbols like here, this is 85 degrees at point A. Okay, they're referring to this angle. This angle over here is going to be what? Maybe 84 degrees. And let's say 74 degrees, sorry. Okay. And we need some information. We're going to say that this distance down here is maybe 12 miles. Okay? So they're giving me this distance here. What they want to know, I'm going to draw this line here. Let's call it this here C. Okay, here's C. They want to know this. What is the length of AC? Question 1. Question 2. What is H? Okay, so what they're asking me now is they want me to find this length, okay, from A to C, and then they want me to find this length, a horizontal distance, H. Okay, now, what do we have at our disposal? Do you guys know what we have? What do you think we have? We have law of sines, law of cosines. Okay, so this is just doing, I'm not even putting any words to it. I'm just actually putting just a picture of geometry and trying to find some distances there. All right, you guys okay with that? Trying to do that intermediate step. So what do you guys think you're going to have to do? You have tools. How do you think you find that first AC? What do you guys think? How do you find that first AC? Well, yeah, you're going to find, how about finding what? This angle here. Could you guys find that angle? What do you guys think? Focus right in there. I make the claim you know what that angle is. What's this angle? Huh? Isn't it going to be 180 minus 85 degrees? How do we know it's 180 minus 85 degrees? How do we know that this is going to be 95 degrees? Because isn't this, remember that first week we were here? Right? Isn't this what? Remember that geometry portion? Isn't that a straight angle or supplementary angles here? So you use the idea that there's supplementary angles right in there. All right, you guys okay with that? You guys see what I'm saying? This is some really good stuff. We're using critical thinking. We're going to find that there. So here's what I'm going to say to you guys here. Okay. Focus on this triangle here. I'm going to do see if you guys can see what I'm saying here. You guys see that triangle? Can you find AC? What kind of triangle is this? If I said to you, first of all, what are you given? This is going to be, for this triangle here that's in gold, isn't that a what? What kind of situation is this? Angle, side, angle. Is that true? All right. Now it's angle, side, angle. And I'm thinking to myself, man, maybe I should do a worksheet. So if this is angle, side, angle, what do you think we do with this? Yeah, you can get, remember, when you had angle, side, angle, well, I mean, if I call this really what? Yeah, you're right. The first step is what? Get this angle. 180 minus 95 minus what? 74 degrees. Is that true? Right? We're going to get this angle right up in here. Okay? So what angle is this going to be? Is that 11 degrees? So this is what? 11 degrees now. So if I go back, we just found that missing angle. Because remember, this is the approach we use when we start to investigate what's called what? Law of sines, ladies and gentlemen. This is a law of sines situation. So if you want to call AC here, x, you say, oh, can I find this length x? Sure. What do we know? By law of sines, what do we know, ladies and gentlemen? Tell me if you guys agree with this. This 11 degrees is opposite the 12, right? So what we know here is sine of 11 degrees over what? 12 equals, what does that equal? Sine of what? Remember, they have to be opposite. 74 and x are opposite. And let me use a different color. I have no idea. Green. Okay, you guys okay with that? So you can say what? Sine of 74 degrees over that x. So I want you guys to compare and contrast. Hopefully you guys see this, because this is going to be, again, law of what? Sines. We could get that angle. I'm sorry, that side called AC, which is x. Okay? And so cross multiplication. You guys know what you can get. What do we get here? X equals 12 sine 74 divided by sine of what? 11 degrees. There you go. 12 times sine 74 divided by Sine of what? 11. So this will be 60 point what? 5 miles, because this was in miles, that length, right? So you found that first answer. That's 60.5 miles. Easy breezy lemon squeezy. Maybe not at first. Maybe not at first, but let's get rid of all this color. You know, this is one of the reasons why solving triangles was so important, right? Because it's going to help you get some of these answers. So this would be 60.5, this length here. And we'll still cover it, color that one red. Okay. Now, can we find H? How do you get H? Yeah, what is H? You say, I have to now focus on this triangle here? Yeah. What do you know you have? You have what? An angle and a on the side, don't we? So for this triangle here inside, we have an angle and we have a what? Side. How do we handle that situation? What's the relationship? Is that a hypotenuse? Is that a hypotenuse? And then, yeah, AC. We just found that 60.5, right? So what I'm saying is that great triangle that you guys are looking at now. Think of some work we did there. Did we do any right triangle work? You guys remember that right triangle? Well, be careful here. This angle is certainly 90 degrees, but don't think law of sines, law of cosines. Think right triangle geometry. So this is the opposite side of what? 85 degrees, and this is a hypotenuse? You see what I'm saying? So don't go to law of sines, law of cosines. It doesn't apply to that 90 degrees. So you say, what's that definition of opposite over hypotenuse? Anybody remember? What is that sine? So for question 2 now, we know what? Sine of what? 85 degrees. What does that equal? H over what? 60.5. So then H would be 60.5 sine of 85 degrees. $60.5 times sine of what? 85 degrees. And what do you end up with here? 60 point what? 3. So I want to share with you guys a very common picture in a lot of applications. Okay, they give you a very common picture in a lot of applications here. Okay, what do you guys see here? That's kind of like, I didn't even put words. Didn't notice that. What did I put? I just put a geometric shape there. Okay, and we get to use law of sines, law of cosines to find various parts. And again, that's why they want you to solve triangles to the degree that you've had to do that, all that practice. Solve this triangle, solve that triangle, solve that triangle. Now you can apply a little bit of it. Okay, what do you guys think? Is that easy breezy? Maybe not the first time, but the second time, you'll go, hey, I think I've seen something like that before. And that's what you study. Okay? You guys know what I'm saying? But when do you study it? Do you want to learn it the night before? You guys want to be like the Dodgers? You only practice the night before? What happened to the Dodgers this year? Horrible. Is that right? What do you think? Did they just practice the night before? I hope not. Because they couldn't hit any fastballs. They were slow. Slow with those bats. That's what the Dodgers did. All right, let's try this. Let me give you guys another picture. I'm going to say something about these two lines, though. You already know something? These are what? Parallel lines, just so you guys know. Parallel. So here we're going to say this is going to be 46 degrees, or maybe it looks a little bit bigger, so I'm going to say 50 degrees. I kind of want to be somewhat to scale. This will be 72 degrees. This distance is 12 miles down here from A to C. Okay? So I'm just going to color this to let you guys know there's a distance there. Here's what they're going to ask you. Question 1. What is the length of the line segment? And that really, if you guys really want to know some notation, you know, that's really the length of the line segment from AC. So, you know, using a color, this is what they mean. So when I should have put here in this question, that means length. I actually put it in words, so I'm good. Okay, so I'm communicating here the length of that. But when you just see the symbol for question 1, you know, this is what they're talking about. Okay, so just to kind of give you guys some geometry notation, they want to know that length. Now, if you want, again, you could call it what? X. So that's question 1. Okay? So how do you think we can find that? Anybody know? How do we find this? Do you remember that geometry that I gave you guys in the first week? Remember we said if these lines are parallel, right? What do we just create here? What do you guys really see here? If this here is a line segment, you call that one L. What do we know about that? Anybody? This is 50 degrees. Where does that go here? Right there. Because what are you guys looking at here? What is this called? This was called a what? This is a transversal, is that right? So you guys have a transversal here. This angle is what? 50 degrees. You guys with me on this one? Good. And then you say, well, if that's 50, that means this is what? 72 degrees. You say, why is that 72 degrees? Because what are you looking at? You're looking at a what? A transversal. Why is this a good thing for us? What do you guys have here again? What is this called? I make the claim this is angle, side, angle. Why is this angle, side, angle? 50, 12, 72. So what's the first thing you guys do for angle, side, angle? You get the third angle. Is that right? Because this is law of what again? Law of sines when we actually have angle, side, angle. So you have 180 minus what? 50 minus what? 72 degrees here. So it's always a good idea. Get that angle, 180 minus what? 50 minus 72. And you get now what? 58 degrees. Here you go. And there it is. So far, so good. So here we go. Here's what we're going to do. Didn't we say we're going to use law of sines? What's law of sines? Sine of 72 degrees over what? X. What does that equal? Sine of 58 degrees over what? 12. All right, remember this? If you have an angle and an opposite side, you can find by law of sines when you have another angle and a missing side. Set them equal. And then you cross what? Multiply. What do you guys think? All these colors kind of, I don't know, you guys like the colors? I don't know. Sometimes they seem a little distracting. They defeat its purpose. So here you go. X is what? 12 sine 72 degrees over sine of what? 58 degrees. There's X. So we have 12 sine 72 degrees divided by sine of what? 58 degrees. 13 point what? 5. Okay, 13.5 miles. And there you go, ladies and gentlemen, 13.5 miles. So you're right here. You found what they're asking. 13.5 is that answer right in here. So maybe we change the color. We go, okay, 13.5 is that distance. Now, is that pretty good? All right. And so now what they're going to do is this. They're going to do this here. They're going to call this H. So they're going to bisect angle C. They're going to create a 90-degree angle right in here. And they're going to ask you for H now. Okay? So I'm going to erase all this other information just so it doesn't distract us. I guess that's all I can erase. What I want you guys to notice now here is take a look. I'm going to keep the color green. Focus on this what? What is this? Isn't that a right triangle? Do you guys see what I'm saying? So this is kind of the theme. You're going to now get a right triangle, and they want to test you. So that's why in the beginning they say, what's this right triangle stuff, right? So you're going to have at 50 degrees, here's opposite and what? Hypotenuse. Well, of 50. If I use this 50 degrees now, don't I have opposite over hypotenuse? So what ratio is opposite over hypotenuse now? For H, if they want to find H, because they're going to say now, question 2, what is H? Opposite over hypotenuse. Isn't that sine of 50 is opposite over hypotenuse? Let me double check, okay? Let's double check here. Yes, in the right triangle, we found the hypotenuse of 13.5. That green triangle. So sine of 50 by definition is H over 13.5. So ladies and gentlemen, here's the deal. Solve for H. How do you solve for H? Right? H will be 13.5 sine 50 degrees. Okay? So, by calculator, what's the deal? 13.5 sine of what? 50 degrees. So what do you end up with for H? H is approximately what? 10.3 what? Miles. This is 10 point what? 3 here. Okay, so that's how you get H. Easy breezy, lemon squeezy. All right, what do you guys think? Okay. So I'm going to do something like this. Over here. A and B. Let's say this is 150 feet. Okay, and this is going to be C. 85 degrees, 55 degrees. I'm going to call this D. How do you think we're going to find D, ladies and gentlemen? Okay, I'm going to say to you guys this question. Determine D. So I'll give you guys a few minutes to think about that one. Okay, give you guys a few minutes to try this. See what you get. Get the audio. We're back. Sorry about that, you guys. We're finding by law of sines that missing side. So let's clear this out. 180 minus 55 minus what? 85. This is now going to be what? 40 degrees. Okay, you guys okay with that one? That's 40 degrees there. There you go. Now, why is that important to know? Anybody want to tell me? Well, yeah. So pick a right triangle. You want to pick the left right triangle? Here's a right triangle on the left. Pick a left right triangle. Pick a what? Pick a right triangle. Which one do you want? Okay. So you say, I want the left. Well, then you know what you have to do then is get this here. You say, what is that? That's AC. You can call it X, right? So find that distance. So how would you find that distance? Very easily. Law of what? Sines. You say sine of 40 degrees over what? 150. Yes. Equals. So you're using this. Sine of 40 over 150, what does that equal? Sine of what? Sine of 55 over X. Cross what? Multiply. Is that right? So if we cross multiply, what do we get? X equals 150 sine 55 over sine of what? 40. $150 sine 55 divided by sine of what? 40. You now get what? 191 point what? 2. So 191.2. So you're going to get this distance over here. All right, you guys okay with that one? 191.2. All right, now you say, am I in the position now to get D? I'll say you're absolutely in that position. Right? So what does that actually mean? In relation to the 85 degree in green right here, right? See this angle. What definition do I use that has, let's think about this. This is the hypotenuse. Is that right? This is the what? Angle. And what side is this? This is opposite side. Is that true? You're looking at the green triangle? Is that the opposite side? So what is opposite over hypotenuse? Sine 85 degrees. The opposite side is D. The hypotenuse is 191.2. So that means D will be 191.2 sine of what? 85 degrees here. Let's find what D is. What is D? What is it? 190.5. 190.5. There you go. So, as you guys see more and more of these, you guys go, okay, I see what's going on here. Is that right? Okay. So they're going to make use of, just some fundamental facts in geometry, like a transversal, and knowledge of a right triangle, and knowledge of law sines, law cosines. Okay. All right. So I'm going to look at a few more here. Maybe. Okay. Do some more geometry. ABC. Oops, sorry. So this is 20 degrees. This whole thing is 55 degrees. This length down here, ladies and gentlemen, we're going to say the following. It's 200 feet. Okay? In blue. I'm going to say here, we're going to call this here as well H. I'm going to say, what is H? So H now is just this distance here. Okay, should we let you guys have a few seconds to think that one over as well? Okay, think of an approach. I'm going to give you guys a hint. Yeah. I make the claim here. You have angle, side, angle. That's the claim I make. Okay. I'll give you guys 5 minutes. Okay, you guys ready? Take a look at this. What are they communicating to us? I make the claim we can get this angle. What's that angle, ladies and gentlemen? Do you guys know what that angle is? It's going to be 35 degrees. You say why? Because they're saying this whole thing is what? 55. Is that true? And then they're saying that this angle from here to here is 20. So if you take the 55 degrees minus what? Minus 20 degrees, do you get 35 degrees? The answer is what? Yes. And I make the claim, you know this angle too. How do I know that that's the issue? You know what I'm going to do here? What is this if I do this? Guys, see what I'm talking about? What am I drawing here? I'm going to say this is L1, this is L2, and then notice this whole thing here. Isn't that a transversal? So what I'm saying is you can notice that you actually have a what? Transversal. And if this is 20 degrees, that makes this what? 20 degrees too. Which means if you have a corner, what's the corner measure? Right in here. Because you have a transversal, 20 degrees, and then you have a right angle. Isn't that 90 degrees? So this is going to be a total of what? 110 degrees right in here. Okay, so notice I'm just drawing a transversal. This 20-degree angle is the same as that 20-degree angle, and now you have a 90 plus 20 gives you that 110. So altogether, if I copied some of this, or if I kind of described it this way. Let me go back. What I'm saying is you have a picture of 35 degrees, 120 degrees, 200 feet, H. I want you guys to see that there. That I use transversal information to find those angles. And again, I made the claim earlier that this was really what? That's angle side angle here. Okay, so we had to find, in short, 35, 110. We were given 200. Okay? Now, you say, how do I find H? Very easily. What is H? Sine 35 degrees over H is going to be, we never got what? Wasn't that always the first step in law sines, right? 180 minus 110 minus 35. What does this give you? Do you guys know what that gives you? 70 minus 35. Is that another 35 degrees? Okay. That's another 35. So now what does that mean then? It means you have sine of 35 over 200. This is, or over h. What does that equal? Sine of what? Over what? 200. Now, I don't even have to do any calculations here. You know what this is going to mean, ladies and gentlemen, just by default? H has to be 200, right? You say, how do I know? Well, you have a fraction that's equal. Same numerator. That means your denominator has to be the same. I don't even have to do any use of the calculator. Now, this is kind of a, I don't want to say it's a bad example. It's a good example, but you know, typically you probably aren't going to find h being the same. Okay, you'll probably have to use laws. You have to do computation on your calculator. There it is. Okay, you guys okay with that one? Good example. Now, you say, what have we been doing?